Hello, my name is Duc Ngu. I'm currently a graduate student at University of Texas at Arlington. So today I'm going to talk briefly about my poster presentation, which is going to be about the mutation in U1 small nuclear RNA going to affect on the U1 SNRP biogenesis. So I'm going to talk briefly about some um, background information. So as you know about the central dogma molecular biology, that DNA need to be transcribed into mature messenger RNA and then translate into the protein as the active nucleotide in our um, living system. So for the messenger RNA, they need to go through some maturation steps like 5' capping, splicing, and polyadenylation. So for specifically in splicing, they are usually facilitated by the spliceosome. So spliceosome are the RNA protein complexes, which is composed of many small nuclear ribonucleoprotein like U1 SNRP, U2 SNRP, U4, U5, and U6. So to initiate the splicing, so they need to have the U1 SNRP bind to the 5' splice site of the premature mRNA. So that is the growth of U1 SNRP in the initiation of splicing. However, you want to also have the roles in telescripting, which you want SNRP bind to the cryptic polyadenylation signal, and then prevent the cleavage and polyadenylation machinery bind to it to cleave the premature mRNA, and then they can produce the full-length mature messenger RNA. So similar to the mRNA, U1 SNRP, U2, U4, U5, U6 also need to go through some biogenesis pathway from this nucleus transportation to the cytoplasm, and then recruit the RNA binding protein, and then got transport back into the nucleus for its own roles. Recently, in 2019, many group of research found that in many pan cancer, they're going to have mutation at the U1 snRNA, the small nuclear RNA at the 5' splicing site, symbol 1, 2, 3, 4, as well as other site. Okay, especially in the position 3 of U1 snRNA, they found that this site is the most frequent mutation in many pan-cancer patients from A to G or from A to C. As you can see right here, most of in the pan cancer, especially in the medulloblastoma cancer, liver cancer, leukemia, and the lymphoma, they usually have mutation, mostly in the 5' splicing mutation. However, those mutations, whether they're gonna affect on the biogenesis pathway or not, we don't know that. So here in our lab, we investigate on the effect of those mutations by using the high throughput SM core assembly assay. We're gonna have the biotinylate snRNA go through some in vitro reaction assay, then capture by using the antibodies and go for reading at the chemiluminescence. And here's the result of it. As you can see is right here, mutation at the 5' splice site result in almost 75% of the reduction of the SNRP assembly. Or the stem loop, they have depleted around 45 to 50 reduction. And then I want to see whether those double mutation gonna affect it, because most of the patient they carry 2 mutation in the U1 snRNA. So double mutation, they deplete around to 80 to 90% of them. So that's gonna conclude that those mutation in pan cancer may contribute to the U1 SNRP biogenesis pathway. So it's come for my future direction where these mutation gonna affect on the post-translational regulation like splicing and tail scripting. So those we're gonna investigate on that part. And then finally, the interaction of U1 SNRP in the polyadenylation machinery as well. So I want to thank my currently and the previous member of Dr. Soul Lab. And then this work is supported by Startup Fund of the Department of Chemistry and Biochemistry of UTA. Thank you for listening.